Everybody. Thanks for joining me today. Glad you're checking out this video. The topic today is the rock cycle, and hopefully you're like, "Hey, we studied that already." But yeah, we did. We did some work on the rock cycle in class this year. When the buildings were locked down and we weren't able to go back to school, we were in the middle of a unit or near the end of a unit on the Earth's systems, and we studied several, right? And one of them was the rock cycle. And I know for a fact that you guys are going to be doing some work on the rock cycle next year. So hopefully, what we learned in class and this review we're going to do today will be some good background information for you because background information is really important when you're trying to learn something, right? The more you already know about a topic, the easier it's going to be. I mean, think about it this way. Think of your brain as this huge room with thousands and thousands of hooks, like the hooks you use to hang up your jackets and backpacks when you're in school. And whenever you're trying to learn something new, if you have a hook you can hang it on, right? If you have some background information in your brain already, it makes it much easier to learn, right? Imagine when you get to school, when we're back at school, if you try to hang up your stuff and you have no hook, what do most kids do? They just throw it on the floor. Well, think of that as new information coming into your brain. And instead of getting hung up neatly on this hook that's secured to the wall, it just drops away and it's gone, right? The more background information you have on something, the easier it is to learn that topic again when you're studying it or reading about it. And background information is important anywhere. I mean, even if I was just going to go to a restaurant, I might look it up on the internet and see what kind of food they serve. Or if I was taking a trip, I'd look on the internet or look up which way I wanted to go, right? Get some background information in my head to make that experience easier and more rewarding. So, background information is very important. So, if you're thinking, oh, why am I going to listen to this today? Um, if nothing else, it's going to set some good background information for you for next year because you will be working on the rock cycle again. All right, so let's talk about that. The rock cycle, it's not a true cycle like the water cycle. Remember when we studied the water cycle and we talked a little bit about it in that last video? It pretty much goes in that same circular pattern over and over, right? Evaporation, condensation, precipitation, evaporation, condensation, precipitation. It just keeps going in that cycle of a pattern. Yeah. The rock cycle is a little different. It doesn't just go in that same circular motion, right? And if you remember, the three types of rock that exist, they can all change into the other types of rock depending on the situation they're in. So it's not just a cycle, okay? But let's start at the beginning, right? So the three kinds of rocks that we have are we have sedimentary rock, we have metamorphic rock, and we have igneous rock. So if you were going to look at it in its simplest form and try to think of it as a true cycle, it would probably go igneous to sedimentary to metamorphic. Okay, igneous to sedimentary to metamorphic. Um, but like I said, any one of those three rocks can turn into any one of those three rocks, even back into the same rock, depending on the situation. But we're jumping ahead too much. Let's take a look at some rocks here. Hopefully you'll be able to see them. So I have a few rocks that I'm going to try to show you today. Here's an igneous rock, right? You can see all those little holes in there. This is lava rock. And igneous means from fire. So in order for a rock to be considered igneous, um, when molten lava, which is magma on the surface of the earth, right, molten rock cools and hardens into a rock, that is igneous rock. Here's an example. Some other common examples are granite. I don't know if you can see that, hopefully. Here's another one, right? And you can see those, they're called crystals. You can see those dark marks in these rocks. That's an igneous rock that cooled really slowly, and it allowed those like ingredients to kind of pull back together and form these crystals, right? So granite is an igneous rock that has cooled slowly. I tried to find some black glass, some obsidian at the beach. That's where I got these rocks, by the way. My wife and I were at the beach the other day looking for sea glass, and that's another story, but some beach glass. And I started to look at these rocks and started to think about the rock cycle again. And I was really looking for obsidian, Look that one up. Look up black glass or obsidian when you're done with the video. It's really cool stuff. That's igneous rock that cools very quickly, right? So they form different patterns. Their molecules form different patterns, and they become different rocks depending on how fast they cool. That's a few igneous rocks. Um, Here's what's called a conglomerate. A conglomerate, it's kind of like chunks of rocks and sand that have been fused together, and it forms a solid rock, but you can see the pieces in there. Here's another one. Now this one I'm not sure, could just be a chunk of cement that was broken and laying near the water at the beach. I'm not 100% sure because this kind of looks like cement, but usually cement has smaller stones in it. These are pretty big stones. So I think that's just a chunk of sedimentary rock that formed naturally. I don't know if you're going to be able to see this, but if you look close, you might see the layers in that one. It's a piece of sandstone. All right, sedimentary rock is formed from sediments, and we'll talk about all the things necessary for these rocks to form in a little bit. But these are sedimentary rocks. All right. The third, metamorphic, that's the hardest for me to find and pick out. I am not an expert. I'm not a geologist. So I looked up a few, and schist is one of them. I think this is schist, schist. It is a metamorphic rock. Another one is shale. I know shale is a rock that if you try to split it, it'll break into pretty flat layers. So again, I'm not 100% sure, but I think these are all metamorphic rocks. Here's another one. Okay. Um, and I'm not, like I said, not an expert. So if an expert watches this video and says, "Hey, that's not a metamorphic rock," hey, comment. I'm always open to learn. And um, I was at the beach and I thought I'd try to find all three. All right, so let's talk about what it takes for one of these rocks to form. So you heard me say before that igneous means from fire. So when so molten lava, if it's on the surface of the earth, or magma, if it's underground, cools down and forms a rock, um, that rock could turn into sedimentary rock. All you really need is some weathering and erosion, right? If that rock is exposed to the elements, wind, rain, snow, ice, melting, cooling, and it breaks down into little bits and pieces and flows downhill in the runoff that we learned about, right? It rains and it flows downhill and it gets into a body of water, and those little bits and pieces of rock that used to be a big chunk of igneous rock, they all settle down to the bottom and they form a layer. And as more and more sediment falls on them, they get pushed deeper and deeper down. And sooner, after a long period of time, if they're down deep enough and there's enough pressure down there, they'll get fused together to form a to form a sedimentary rock. So we went from igneous to sedimentary by the use or because of the natural forces of erosion and it flowing downhill into the body of water and settling down, which is where the word sedimentary rock comes from, and it's fused together. And sometimes that happens and the pieces are bigger, right? This is a conglomerate that was fused together, probably deep at the bottom of a lake, river, stream, something like that, and it was down there a long time and it was deep enough where there was enough pressure going on and it fused it into a solid rock. Okay. um, Metamorphic rock, to morph means to change. So what happens is, let's go back to our chunk of we went from igneous, right? Rain, snow, ice, sleet, wears it down, bits and pieces flow downhill into the river, gets pushed deeper and deeper, and forms into maybe some sandstone, right? Layers of sandstone, and then that rock gets pushed deeper and deeper, and soon it's so deep that it's hot, and there's a lot of pressure, right? A lot of heat and pressure will cause a rock to change chemically, right? The heat and pressure will make the molecules rearrange, and it'll go from sedimentary to metamorphic. And then you have yourself a metamorphic rock, right? To make a metamorphic rock, what you need is heat and pressure. To make a sedimentary rock, what you need is weathering and erosion, okay? And what you need to have a igneous rock is melting and cooling. So if you think about it, any one of those three types of rock can form into any of the three types of rock. For example, you have this igneous rock, right? And let's say it's under the ground, because that's where a lot of igneous rock is, deep in the ground. Let's say some seismic event happens, there's an earthquake or something shifts and this rock gets pushed even deeper, or an explosion occurs or a crack opens up and magma flows on top of this rock, right? It's already an igneous rock and it melts and then it cools. That means it went from igneous to igneous, right? So an igneous rock can melt and cool and become an igneous rock. This same igneous rock, right, can get pushed deep enough where there's enough heat and pressure, not enough heat to melt it, but enough heat to change it chemically. And it changes chemically. And then that igneous rock has become metamorphic. And you have a metamorphic rock, right? So this igneous rock can become any of the three. And the same goes for sedimentary, right? This conglomerate could get pushed deep enough down where there's heat and pressure and it changes into a new kind of rock chemically because of the heat and the pressure, right? Um, it might get exposed. Like when I found this the other day, it was exposed. It was on the surface of the earth and the waves were rushing over it over and over. And when it's cold and it freezes and water's in there and it breaks it apart because the ice expands and cracks it up. I mean, this might have used to be a huge rock and now it's just as big as my hand, right? This was getting worn down. And if a sedimentary rock is exposed to the elements and it's worn down and it gets back into the body of water, it can resettle and become another sedimentary rock. So sedimentary can become sedimentary, right? Sedimentary could melt and cool and harden and become igneous, right? So the point is that any any of the three types of rock can go through the right processes to become any of the three types of rock. So where you think of um, the water cycle as this cycle that goes in the same direction, right? Evaporation, precipitation, um, evaporation, condensation, precipitation, evaporation, condensation, precipitation. It's the same. It's not so much with the rock cycle, right? Igneous can become sedimentary. Igneous can become metamorphic, or igneous can melt and cool and become igneous. And it's the same for all three, right? Metamorphic rock could melt and cool and become igneous. It could get exposed to the weather, get broken down, and end up in bits and pieces as sediment in the bottom of a river. And that means this metamorphic rock is now becoming sedimentary rock, right? So that's what I meant when I said it's not this exact cycle like a water cycle, right? I don't know what exactly you might want to call it, so we just call it the rock cycle. And if you do a quick search, and we did this in class, if you do a quick search for the rock cycle, you'll see that each one can become each of the three. And that's what's really interesting about the rock cycle. I plan on putting thumbnail for this video. I'll put up a picture. So before you start, or when you're done with the video, take a look at that thumbnail, that picture that's just frozen there on the video. You'll see an example of a drawn rock cycle where any one of these three rocks can become any one of these three rocks. And that's the rock cycle. Hopefully you remembered some of that from class. I know it's not the most exciting video. It is not a video that is setting up an experiment. Um, as of the making of this video, which is on May 7th, we have the icicle. Icicle. We have the ice cube in the freezer, and we're waiting to see if sublimation is going to take place, which we would see the ice cube shrink. And early next week, we will set up a mold growing experiment. That video has not been made yet, but that's the next one on the list. So hopefully you'll check back for that one, and hopefully you got some good information off of this one. So thanks for joining me today, and hopefully we'll see you again. Take care.